Wonderful. So, yeah, great to be here. Only just literally got back from Tel Aviv, as I was mentioning to Joe just a minute ago. It was this horrible 26, 28 degrees yesterday in Tel Aviv, but luckily I'm back down to a much more reasonable temperature now. So yeah, I'm really pleased to be here to talk to you about serverless, security in serverless. We're going to cover some kind of higher level ways in which we can kind of secure our deployments and secure how we build applications for serverless. And there's going to be an amount of breaking in as well. So we're going to show some typical exploits and show some ways in which we can be a little bit nasty with some of our applications. A little bit about me. So I'm very much on the Java side. Any Java people in? A few. Cool. What else do we have? Like some Node or JavaScript? A few. Some .NET? A few. Some Python? Whoa, loads of Python. Cool. What else do we have? Some cool things like Go, Rust. A few bits and bobs there as well. Anything I didn't cover? PHP, we're all friends. Come on, we're happy to, that's it, cool. Right, so yeah, I'm very heavily based in Java. I've been a developer for 20 years, joined IBM way back when, worked on WebSphere application server for about 12 years as a developer. Any WebSphere users? One at the back, probably right to sit in the dark at the back there, but no, I'm joking. So yeah, I did that for about 12 years, and now I've been into developer advocacy for around the last 8 or so. So I run the DevRel team at SNCC, and I'm also got some other awards and things from being in Java for too long, probably. So as I'm kind of got a Java background, the apps and things that we're going to be using today are going to be in Java. But realistically, we don't really care too much when we try and attack into serverless. It doesn't matter what the implementation necessarily is. But what we're going to be using here today is a Spring application. So we're going to give a brief introduction to kind of like what Spring Cloud Functions are. We're going to hack that application, and we're going to go through a number of different flaws that are going to exist in the deployment that we provide, that we're going to use as an example, and how we can then go ahead and fix those. Okay, so let's start a little bit higher up when we think about how we kind of move on to a cloud platform. Very often we start with more of a monolithic app, and when we think about our monolithic app, that is going to typically run on a VM, which is going to run on top of an operating system. We kind of choose all of that. And that then runs on a cloud platform, and things like the hardware are the things that are abstracted. The operating system and things like that are our maintenance problems. So we need to make sure that our application, which is typically a number of functions, a number of services, not necessarily microservices, but a number of services that exist in the same process, will all run together. From the app to the OS to the VM, we try and look after as much as we can. But then when we think a little bit closer, when we go into something more maybe like containers, we get a lot more flexibility. We can actually utilize our hardware a lot more because we can run multiple containers in the same VM. We can scale different containers as well. Rather than scaling a massive VM with a massive monolith, we can scale more granularly. But if you look at what's in that VM in the containers, the operating systems are still there. We can choose which operating system we want to run in each of the containers, but we still have to maintain that operating system. So the hardware utilization is better. The flexibility in the OS, as we can choose, is better. The portability somewhat is better as well because it's a lot easier to kind of move those containers around to different vendors. And elasticity is very, very easy because we can scale on 2 ways, the VMs or the containers. And then, of course, when we move to serverless, we see more and more being pushed into that cloud platform. And what we really see as we go left to right is this difference in a shared responsibility between you as your application creator and the vendors of the cloud platform that you're choosing to deploy. So what's being pushed in now? Well, more of the VM, the operating system, and this is now the responsibility of the vendor to keep this secure. So as you're spawning up and spinning up new instances, you would expect that to be running on operating systems with the latest patches and things like that. When it comes down to what we need to provide onto these platforms, well, we're just throwing code around now, of course. So we can write this little bit of code for what we would think would be kind of the best portability. Of course, we have the config that we need to make sure will work across the serverless vendors, but from the point of view of what we're actually writing, it's a lot more portable. So from the cloud platform then, no hardware management, no OS management, and elasticity-wise, it's elastic, it grows and shrinks as we absolutely need. PaaS kind of sits in the middle here on this kind of view, and I'm sure lots of people have many different views, but in this kind of way that we're looking at it, PaaS is kind of in between. So, as I mentioned, I'm a Java person. We're going to be doing this demo in Java. Hopefully, not too many groans, but when we look at the different cloud approaches that are used by Java developers, we can typically say this is actually a year old, so I would expect this to have probably moved on a little bit since, but the numbers are fairly relative. We had about over 10,000 people take this survey, by the way. Serverless and PaaS are actually fairly level on this one, which is kind of interesting. So that's kind of the approaches that the different JVM developers are using. When it comes down to the cloud platforms, we see obviously Amazon, as we know, having pulled out Lambda support and things like that. Very key in terms of what we're going to be doing today. I'm going to break this into three different pieces that we're going to choose to use for our example today. First of all, the actual platform. We're going to be running our examples on Lambda, but of course none of the example hacks and things like that are going to be specific to Lambda. But this is typically where a lot of the kind of the compute work happens, the event system happens, and things like that. The deployment model we're going to be using today is going to be serverless, so we're going to be deploying our applications into Lambda with serverless. And the programming model that we're going to be using in our application is going to be something called Spring Cloud Functions. And Spring Functions allows us to use a kind of Spring Boot model, which kind of wraps everything up nicely in one nice jar, which we can then execute as a function. Okay, Spring Boot, for those of you who aren't Java, you've probably heard of Spring Boot before. Spring is an MVC framework. It allows you to obviously write your applications. It was kind of the the answer to EJBs many years ago, back in the early 2000s. These days, Spring Boot seems to be a very de facto thing that is used by Java developers, and it effectively bootstraps everything, wraps up a nice little jar for you, so that you're not deploying a war onto a platform, but you're running an executable jar that actually contains maybe a Tomcat or a Jetty under the covers. So, Spring Functions, as I mentioned, it's a bean. It's a Java bean. It's a Spring bean, which actually, with the surrounding libraries, gets turned into a cloud function. It is still pretty heavy in that the Spring framework was originally the lightweight kind of version of an enterprise application, a EJB, but these days it is getting pretty heavy. It is getting into something quite a sizable jar. I always joke with our CEO, well now president, because I'm a very big Java person, he's a very big Node person, and we always joke about this, whether Java's better or Node's better. And when I was creating this application, I think this application, because we include all of Spring and things like that, it turns out to be a 20 meg jar, and it felt way too big for what it was actually doing. And then I was actually trying to deploy this and look at it running in Lambda, and the way you actually have to deploy it for multiple functions is you pretty much copy that entire jar many times. So I pushed up 6 functions, and I'm actually pushing up 120 meg every single time on hotel Wi-Fi at the time. And yeah, he won that battle, but the war's still not over. So we're going to start when we think about the application that you write, the function that you write, and this is a really key thing when we talk about the first piece of how we need to secure our serverless functions. Your application, from a very high level, looks like this. And when we think about what it is in the application that we write, it could be config, it could be properties, could be code, but actually that part is a very small part of the application that you write. And what the rest of that application is what you pull in, the dependencies and libraries that you pull in to make your application actually work. And when we think about where vulnerabilities in applications exist, and this is a key thing because the more that gets pushed into the platform from a serverless point of view, the more we need to look at our application as well as the config in our environment. And our application contains huge numbers of vulnerabilities in our dependencies as well as the code we write. And from a dependency point of view, here we can see the split between where vulnerabilities exist both in direct dependencies that we explicitly say, I want to use this, and the transitive dependencies, the dependencies which our directs also rely on in order to work. So when we package all this up, we see vulnerabilities in both of these. So vulnerable libraries is our first tip. And of course, everyone has likely heard of this well overused example of Equifax as being one of the kind of headliners for what happens when you don't upgrade your libraries. And I'm not going to talk too much about Equifax specifically, but I want to talk about the first hack that occurred in Equifax, and this was Struts. And Struts is a web framework in Java, and the hack in Equifax only occurred a couple of days, 2-3 days, I believe, after the disclosure for this vulnerability, including a live exploit, which typically just gets uploaded to GitHub somewhere, was made available. And the number of attacks that are then occurred is very easy for anyone to really just run this demo code and try and find some Struts endpoints to be able to run some executable code. So I'm going to go and actually show you this hack that occurred on Equifax. So this is my just a regular to-do application, so I can sign up here. Simon. I'll just use 1 to 6 as my password because this is a security talk. There we go. So here's my application. Typically on my About page, you wouldn't see this kind of information, but here we can see this is using the Struts, vulnerable Struts framework. So what we're going to do now is we're going to attack that very, very simply by sending a header. And this header provides a content type. This is a very, very easy attack to do as a result, because the content type that we pass, we just need to pass this as part of our header in our data, and any request that then goes to this endpoint becomes vulnerable. I'm not going to go too much into depth here, but the reason that this is the reason that we go down this exploit path is because we provide an illegal content type that takes us down an exception route, and as a result of this little piece in our content type being evaluated by a library called OGNL, during the evaluation, we are able to execute our own code, which provides us, in this case, with being able to run a new process builder, passing in bash, and we can then run whatever command we want in bash with the permissions that this process is giving us on that system. So if I were to show you that actually running. Let's copy that. Let's pop that there. What I'm going to do now is I'm going to cat that header file. I'm piping that into, just a substituting the command for env in this case. And then let's send that to my Heroku instance just here. I know this isn't a serverless example, but I just want to show this one. And then we pipe that across. So by running this is going to hit a Heroku endpoint. Hit a Struts endpoint. It's going to go down an exception path. That exception path is then going to evaluate that information, running bash, running env, which is going to get us the environment variables of our machine, and there are the environment variables of that Heroku machine. So very, very easy. This was the first hack that occurred with Equifax. The key to this, of course, is keeping our vulnerabilities up to date. This is just as important, if not more important, on serverless than any other deployments, because on serverless, less of the OS issues, less of the OS vulnerabilities exist because you are more likely to be on a higher version, on one of the later versions. So let me jump back to here. Yes, this one. So serverless does secure dependencies from the operating system point of view. So we don't need to make sure that we are necessarily on a very specific version or having fixes, because we're going to be on a latest version. However, our app dependencies that we actually deploy up in our serverless app are very, very important. And this is key because the number of we also give a talk called Stranger Danger, and the strangers here are the people who provide the packages, the dependencies which our developers use, and we pull them in irrespective of who's the author. We don't even look at our transitive dependencies because we're thinking more functionally and less about security. We can see NPM, in fact, has gone over the 1 million mark these days. I spoke to the guy on Twitter who thought he created the 1 millionth NPM package on the NPM registry, and I said, how do you know you did that? Because you get no feedback about what number it is. And he said, oh, I'm sure, because what happened is I wrote a script that worked out when it was 999,960, and then I wrote that script to automatically deploy 40 packages to the NPM registry. And I guarantee those won't be the worst NPM packages on the registry either. But here's an example of how 222 lines of code, which is the application that we're going to now be hacking, has 5 direct dependencies, right? In those 5 direct dependencies, we obviously have a number of transitive dependencies. And when we think about the application, our function, how we keep that up to date, we only have control of our direct dependencies. That's the only thing that we actually put in our function Maven file or package JSON. That's what we can control. They then have a further dependency on these other transitives. So the thing that we need to make sure is, first of all, any vulnerabilities that exist in your direct dependencies, you migrate up to a version that eliminates or fixes that vulnerability. And we should know where vulnerabilities exist in our transitive dependencies, and we need to pull our direct dependency up so that it pulls in transitives at non-vulnerable versions. So this is the thing that we need. This is the key thing that we need to work out. So of those 222 lines, just of the code that I write in my IDE, how many? Just shout out. How many lines of code do you think we're actually going to be deploying onto Lambda, including transitive dependencies and code that I'm writing? What kind of numbers do you think? 10K. 10K. Any increase on 10K? 20,000. I need a gavel. Any increase on 20,000? 100,000, I presume. Almost 500,000 lines of code. Okay, and when we think about securing our application, we always think it's the code in my IDE that I need to secure, right? But it's not just that. It's about, we need to think about it from the application point of view. So the attack that we're now going to make on this app, which is actually running in a live Lambda right now, is going to be a deserialization of untrusted data. And all those Java people who are almost certainly using Jackson somewhere are going to know exactly what this kind of vulnerability is. Deserialization is a big problem anyway, and it's a problem irrespective of security that needs fixing. Serialization can be useful, but can also be a big problem. But when classes, objects, whatever it is, whatever data we are deserializing needs to be reconstructed, we typically go through a read object phase. And in this read object phase, we're not necessarily constructing objects in the typical way where we kind of pass in variables and have that object called with setters and things like that. We call read object, which creates that data structure for us. And that read object is something which would typically be done by the standard object class in Java, but we can, of course, override that. So I can write whatever malicious code I want in the read object file, which, as a result, can then be potentially damaging. So a deserialization of untrusted data, the one that we're going to attack here is going to be in Jackson, and it's an extremely high CVSS score. The thing that we're going to be passing across is simply going to be a bash argument with or a Java bean with a bash argument that gets called when the class is recreated, and then I can pass whatever malicious command I want to. So let's actually show this happening now. So my application is just a regular to-do application. To-do application which is running on which one do I want? This one, which is running on Lambda right now. And in fact, I'm going to use Snyk now just to test this, but I'm not going to show the tool too much. I just want to, by the way, this is a tool which you can use for free if you want. It's the company I work for, but I'm not going to go into it too much. I just want to show you the results. And the results are, when this is tested on my application, I can see the vulnerabilities I have, the number of dependencies I have. I can see the issues that I have, and here are the deserialization of untrusted data issues that I have, and you can see where they exist in these in the dependency graph as well. Okay, so once I can scan this, I can see where my issue exists. Now the attack here is on creation of this process builder bean, this class that's going to be reconstructed upon deserialization. We're going to run bash, and we're going to curl a binary file, which is going to be the etc password file, over to an ngrok. And this is just a direct pipe over to my machine. So I'm running an ngrok server here. And if I click on that, we can see any requests that are going to be coming into my ngrok server here. So the thing that we're going to be doing now is I'm going to make a request out to an endpoint which is going to exist on Lambda. It's going to pass in a file, a to-do, which is going to be imported. But that to-do isn't an import to-do object. That to-do just happens to be my malicious content. So again, this is going to be basically trusting someone else's data. And as part of that, we're going to run some code which is going to grab the local etc password file on that Lambda instance, and it's going to then send that to my ngrok, which is running locally on my machine. So let's see if this is going to work now. Over here, got a couple of commands. So here we go, not that one, this one. So we're going to perform this curl request. This is my Lambda instance here. We're going to hit the import function, and we're going to pass in this spell etc password file that I've uploaded to GitHub, which is this file. So I'm going to execute this, and my Lambda is just coming up. Of course, this is a Java Lambda, so we have that fun of enjoying a nice cup of tea or a coffee while this is coming up. But as soon as that comes up, now there we go. I'll run that a few more times, because if you think live demos are hard, live hacking can even be harder. Here we go. We've got a few coming in. So there we go. There's my results. It's the binary etc password file coming from that Lambda. Wow, lots of users on that box. Loads of users on that box. And we can get some information. Obviously, the etc password is the more classic file that an attacker, if you're just trying to show off, you try and get to, but it actually doesn't contain that much information now, as we know. But now we can start executing whatever we want on there. Okay, I was just performing a curl, but I can execute whatever I want. Now, let me take a quick look at the. If I come back and take a look at the serverless YAML. Let's add some. So my serverless YAML file, which I created, and as I'll scroll through this, I'm sure you'll see, hopefully, a number of different security issues that are going to exist in this file. But you can see some allocations of some IAM statements. You can see a whole bunch of different functions. These functions have their own API gateways. So I can access over HTTP. You can see some don't. So backup to-dos, for example, is more of an admin command. So that one I don't want to have an API gateway. But this is my serverless command, which I'm going to be serverless YAML, which I can use to upload and do all my necessary admin on my application. So the first thing is about vulnerable libraries, and typically in serverless, you ignore the OS vulnerabilities because that's, the OS part on the OS scanning, because that's done for you. It's more the application vulnerabilities. Second thing is granularity. So granularity exists in terms of how we deploy, how we construct our deployment. And by talking about the deployment, I'm talking about our serverless deployment here. So if we create a whole bunch of our functions, that's great to keep it modularized and in a more kind of microservice-y functional way. It's nice to do that. But if we try and deploy it all together, at that point we come into a number of different problems. So, for example, here we have some nice endpoints which give the users the ability to actually do some functional work on an application or some functional work in their business. But if we try and deploy that alongside different admins, we actually have perimeters that contain both your admin code which potentially has much higher permissions, as well as our user code. So permission granularity is extremely important, and when we think about that, we look at something like this, and many of you probably saw this and thought, oh, that doesn't look great, whereby we have a whole bunch of actions that are permitted for different functions to use, and a star resource. So, everything can kind of do whatever it wants. It might actually only be that you get a couple of functions that actually need to be able to update items, whereas everything else might need read permissions. And this is a very slippery slope. whereby we continue to add permissions till we get to a star, and then no one wants to pull it down from a star because it's thinking we're going to break something, right? So providing the granularity of our permissions is extremely important to do in a way whereby it's very similar to the least privilege principle, right? You only want to give runtime or processes or whatever it is just enough permissions to be able to achieve what it needs to achieve. Any more, and if something occurs, some issue occurs, some hack occurs, all of a sudden you've got a process or whatever it is with more access than it needs to a database, more access than it needs to a file system, and so on. So deploying granular functions and permissions is extremely important. We know what's easier and we know what's safer. Function ordering is very, very important as well. And what we really mean here is the ability to understand which functions are going to call which other functions. We can't, this is maybe should say, don't assume function ordering. So don't assume that, my function over here is going to call this function, nothing else is going to call anything else, because when we think about how we create our perimeters around our functions, sometimes we might say, well, you know what, it's okay to have some functions here and other functions here which are unrelated because they're not going to call each other. But don't assume that, because if someone hacks into one of your functions and has access to the ability to call other functions without an API endpoint or something like that, gateway, then that could potentially happen. Whereas what we really want to do is create perimeters around everything. And from a hacker point of view, this is about allowing or not providing an attacker who breaks in with more scope, more ability to do damage than they can. If they break into one perimeter, they have access to one service. What is the most damage they can do to that service versus having one perimeter around many services? Okay, immutability. This is an interesting one as well. So immutability. Let's jump over back to our attack. The next one I'm going to run is the ability to list my temp directory. So in this case, what I'm going to do, I'm going to come back to, I'm going to come back here and no, not that. No, not that one. This temp, here we go. So the next one, I'm going to use the same attack in this case, but what we're going to do is we're going to have a look at what's in our, sorry, not our list temp, our find to-do files. What we're going to do is we're going to perform another request. In this case, we're going to just do a find for anything with to-do in it, so any class with to-do. We're going to put that to a file in the temp find to-dos location. And then we're going to curl that file back to my ngrok. Okay, so it's just a fairly straightforward request. I'm going to do this a few times and just make sure. There we go. Find to do files. So I'll run that a few times just to make sure that gets through. Let's have a look. Okay, so there's our hack. We have created that file in the temp directory, and we're now going to get that back. The next thing we're going to do is list our temp directory. So if I was to go here, we're going to list our temp directory, and we're going to, again, create another file called list temp, which is going to be in the temp directory, and that's going to be the results of me performing a list in that directory. And we're going to just then pull that across back to my ngrok. So let's run this one as well. List temp. There we go. So I'm going to run that a few times. So you can see the thing that's changing here is just the file that I'm executing, the file that I'm sending. So if we come back here and check this, what we can see is our temp directory. And what we can also see is both find to-dos and list temp. And what this is showing us is that the instance that this Lambda is running on, it's not being raised up, tested, run, brought back down until the next request comes in. And you can see that, first of all, just because you didn't get that cup of tea moment every single time I made a request. But what we're seeing here is the fact that if an attack occurs, that machine, however long that machine or however long that instance is available for, that machine, I can augment that machine, I can change it, I can maybe install stuff on it, I can, depending on what permissions I have, okay? These what we're running with serverless isn't immutable, and we shouldn't rely on that being immutable. Okay, so don't rely on immutability. Denial of service is another interesting one, because a lot of the time we think, okay, denial of service it's still considered a security issue, but it's considered an issue that maybe goes away when we think about functions, because our functions are way more scalable. It's way more elastic. If we get a denial of service, we just throw in some, more instances come up, right? Well, it's still kind of a problem, because first of all, regular expression denial of service is massively on the rise, or certainly disclosures are. I'm going to show you a quick denial of service right now, which is in a to-do application. This to-do application, I can quickly just show you if I was to do something like buy milk in 20 minutes. Whoops. Do that again. Buy milk in 20 minutes. What it does is it parses. There's a regular expression engine here, which parses my text in 20 minutes. It works out that, this to-do has a number of, an amount of a period of time, and it turns that into a number of milliseconds. As a result, we're just showing it here in this as 20 milliseconds. But there are a number of different ways of representing a regular expression, or parsing a regular expression. In this case, we know this is going to match. We know this regular expression is going to match. We don't know how it's going to match. It might match just with the A+, or it might use, I don't know, it might do this one with the first A+, and then this maybe with the second A+. It likely won't, but I'm trying to say it can be done in a number of different ways. And when we get something like this, which we know is never going to parse and never going to match, some regular expression engines will do this in a backtracking way. So it will go, okay, I'm going to match all these A's. We get to a B. I can't match the B with this pattern. So maybe I'll do this one with the first, all of these with the first A+, and I'll use the star to use this second A, to match this second A. Oh, I still can't match that B. So that it will carry on backtracking through these. And then the more A's that we put on here, the greater the number of steps it will turn exponential. And the amount of time it will take to process this is going to grow and grow and grow. So let me show you a very, very quick way to kind of hack that. I'm not sure if I've got my MS. No, okay. Where am I? Yeah, this is fine. Okay, so if I okay, so what we're going to do here is we're going to echo some content. So we're just going to execute this as an HTTP request. We're going to buy milk, but we're going to do it in 60,000 fives. So we're going to print 60,000 times, and then instead of putting minutes, we're going to type minute A. So let me show you both. Let's just type minutes first. That occurs very, very quickly. There's a lot of minutes there. And if I go back here, you can see we've requested that in infinity days. So huge, huge number. But if I was to, and it matches very, very quick, because the first time it matches, it stops. But if I was to do that, oops, if I was to do that whereby it doesn't match, so turn that from minutes into minute A, okay, so it's going to go through all those 60,000 fives, work out there's an issue, and then try and backtrack through those. If I hit return there, it's hanging. It's backtracking through all those files. If I come back here, it's backtracking. It's hung this process. So now if I make loads and loads of requests here across to my instance, and if I put another 0 on the air, by the way, we'll be here till tomorrow. If I make loads and loads of requests to my serverless instances, what's it going to do? Well, it's going to take out. It's going to effectively expand the amount of instances I have. And while that's not necessarily going to bring it down straight away, it's certainly going to cost quite a bit, because the amount that I'm going to be billed, the amount of time that I'm going to be billed, is going to obviously increase. So this is unlikely to take you down. I mean, there are hard limits, obviously, in which different vendors have. It's not necessarily going to take me down unless it's a massive, like, DDoS attack or something like that. But it is going to cost me. So this is kind of like, we call this almost like a denial of pocket rather than a denial of service, right? It still exists, but it's going to cost. In fact, right, if you're on O2 and you go to Israel, which I just was yesterday, I completely forgot that it costs me 7 meg or something for £7 for 1 megabyte of data, and I think I used about £100 worth, and it took me down. I had a denial of data, but yeah, it ultimately is going to take you. It's going to cost you quite a bit. Okay, so secrets. Secrets, again, in your deployed code, it's going to be increasingly important not to store your secrets in code. And there's a really easy way of doing this. There's KMSs, right? There's key management systems whereby we can just say, let's throw my secret into this KMS, similar to a kind of a vault. And this exists within the platforms themselves. So there's no really excuses here. If you're going to use secrets, push it into a vault, push it into a KMS, and then you can extract it directly from that. And the last one that we really want to focus on is worrying about all functions. And this is something which, because we typically get billed per usage or based on the usage of our functions, we typically don't mind what we have active, because if it's not being used, we're not paying for it. It's not like it's more of a PaaS system where we kind of play for the platform. So what we're looking at here is potentially having a number of different instances of functions, some of which we don't care about, some of which we do care about, but the most important thing is to make sure that everything is secure. Because if we have some things that are not secure, but it's okay because we're not using it, all you need to do is have a hacker break into that, and then they can potentially break into other areas which could have similar permissions, could have the same permissions that other functions might, but we need to make sure that everything, all functions, are secure. Okay, so my summary there is pretty much all the 7 points that we mentioned. One thing that I would say is one of the biggest areas is it's not just about the config and the deployment, but it's very much equally about the code, because when we have this split of responsibility between you and the platform vendors, the platform vendor takes care of a lot, but it doesn't take care of everything. We need to make sure that what we deploy is equally secure. Thank you very much. I'm happy to take questions. One thing I will say, just in and around SNCC, if you wanted to do any SNCC testing, you can connect SNCC directly to your AWS instances, for example. We can automatically test the applications that you're running on that, and we will also find the vulnerabilities that you have deployed. It's not just for serverless. You can connect that directly to your GitHubs and things like that, and automatically remediate vulnerabilities that exists in your repositories by sending pull requests. So it's a really nice developer tool which developers can get in early and fix with actionable advice. Entirely free with limited usage, so you can do 200 tests per month for free, and you can download that and try that as a self-serve as well.